Sup guys, today we're gonna do something very exciting. We're gonna create our own large-scale Linux distribution from scratch. There's two phases. The first is a minimal Linux distribution on a USB flash drive, which is gonna set up the basic system. It contains a Linux kernel, Busybox and a few other packages. It's gonna partition and install the base system. Then it reboots into the hard disk drive and continues the rest of the installation. Let's get started. Sup guys, welcome to today's show. So today we're going to create our very own Linux distribution. Full-size Linux distribution. A lot of my YouTube colleagues have created smaller versions, but I'm gonna create the real thing. I'm gonna call my Linux No Bloat Linux, but you can call your version whatever you want. The installation program is going to have two phases, and phase one is going to be booted from a USB flash drive. And this is going to be a minimal Linux distribution. So this is only for the first phase of the installation. It's going to be based on Busybox, which is a collection of different utilities for Linux. Let's start with phase one by setting up this minimal Linux distribution. And we are only going to use packages from trusted sources. Some of these similar YouTube series uses stuff like, well, I don't want to name names, but there are other similar approaches where they use a whole lot of weird patches from very weird domains and stuff like that, probably backdoored, but not here. We are only going to use kernel.org and gnu.org. So unless they have been hacked and backdoored, it's going to be safe. Alright, so let's start with the Linux kernel, and I'm gonna pick this long-term 6.1 version. So I'm gonna grab this tarball by copying the link location. And I'm by the way, there are two choices here. You can create a 32-bit Linux dist. This is what I'm going to do. Or you can create a 64-bit Linux dist. I'm going to show you how you do both. But if you're going to create a 64-bit version, make sure that you compile everything on a 64-bit system. Since this is a 32-bit machine, I'm going to create a 32-bit system because I like 32-bit systems. I'm not too fond of big registers. I don't think that's very helpful, actually. All right, so let's go into my temporary directory. I'm going to create a directory for this, NB Linux, No Bloat Linux. And I'm gonna set this to my home just for convenience. And I'm gonna wget. Okay, I copied that stuff. So copy link. And I'm gonna wget the Linux kernel. And while I'm downloading this, I'm gonna track the next package, which is libc. That is a standard C library, and almost every program on the system is going to use that. So we are two. So let's go to software and search on the page for libc. And since it's a GNU version, it's called glibc, but it's the same thing. So let's see where we download the thing. We can take it from this. And let's just scroll down to the latest version. Or actually, let me check one thing. By the way, let's start unpacking this with tar. I'm just gonna check one thing. So LDD. 227. Okay. I want to have 226. So let's take this one. Copy link. And you can take the latest one if you want. I'm going to take this for another reason, which I'm going to tell in a later episode. It's not relevant right now. All right, so let's see, where were I? In TMP NB Linux, I'm gonna set this to my home. And I forgot, I want to create one more subdirectory. I want to create specific directories for phase 1 and phase 2. So I'm gonna move the Linux kernel into there, but I don't want to abort this unzipping. So let's go to phase 1 and download glibc here. And while we're at it, let's go to Busybox. And this is not a GNU software, so we need to download it from somewhere else. So I'm breaking my rule already. But this is only for the phase 1, so it's not going to be installed on your end system. Besides, we are taking it from the official website, busybox.net. And I don't know why this site is so slow. It was the same when I experimented with this last time. But it's not much to do. We have to just wait it out. So let's see, download source, that's what we want. These are quite heavy packages, so it takes a while to download and to unzip. And while we're waiting for this, let's go to gnu.org again. And another package that we want, maybe I should make a list. So let's see here. We need the Linux kernel. We need glibc and let's see, Busybox. Then we're gonna need sysvinit, which is the system for booting up the Linux system, basically. So first it goes to the bootloader, then it starts the kernel, and then when it's starting applications, it goes to sysvinit and executes sbin init, which starts every other process on the system. All right, and the good thing about this is you configure everything with simple shell scripts, so you have maximum control over everything. Let's see, okay, Busybox. Here I do want the latest version, which is 137.0. And this is the signature, so we want this. No, this is also a signature. This is what we want, the BZ2. Copy link. We go to phase 1 and we download Busybox, which is probably going to take a while, even though it's not very big. Sysv init is the next one. So we go again to software. We searched on the page for sysv init. Actually, I don't think it's listed on the main page, is it? Which is kind of weird. But let's see how the structure looks. It seems like it has its own folder. So what if we go to sysv, what was that? Sysutils, but that's not the same, is it? Complement core utils. No. Sysv init. Here we are. It's weird they don't link to this on the main page. This is one of the most important ones. Right, so let's see here. Sysv init, GitHub. I don't like GitHub. Let's go to download. Here we are. Right, so search on page sysv init. Let's see what we got. 23304 from 2022. That's the latest one. So it's this one right here. Copy link. And we'll download it here. And sysv init, I want to link against the glibc that I have, that I am downloading here. So we can't do that. But Busybox, I'm gonna it's only one binary, so I'm gonna compile this statically. So we don't have to worry about any libraries. So we can start with this right away. So let's see, bzip2, I think I do bzip2-d and then this. And I don't think this will take very long. And when I experimented with Busybox, I had trouble getting into the configuration program. So let's see if this is still the same with this version. Because you run make menu config, same as when you configure the Linux kernel. But it's a little bit weird. It seems like they have basically copied everything from the Linux kernel with regards to menu config. But we are only going to change one thing, so maybe we shouldn't worry too much about menu config. So let's see. Let's create a standard config first. So make default config. And if we have trouble with the menu config, then we can just edit the config manually instead, since it's only one thing we're gonna change. But let's try it. Make menu config. Maybe it works. No, it complains about ncurses. And I have ncurses and ncurses devil installed on my system. I can show you. Apt get install and this. I think it's called dev. Yep, already the newest version. So this is a bug. However, if we look what this thing actually does, so if we go into the scripts and kconfig, and we open up this make file and search for menu config, we see that it runs this. It runs make and then this program right here. So it creates this LX dialog thing, which it has already done. I think, no. Okay, let's do that manual. Oh, well, it has. I mean mconf. Don't I? Let's see, build script kconfig. Well, inside of LX dialog. Okay, here we go. Got it. So let's go back to the make file. And we're gonna use this config.in, which is located I think in the base directory. Yes, here we have it. So let's do this. If we run scripts kconfig LX dialog, or if we run mconf, let's see, kconfig LX dialog, LX dialog. No, it should be mconf. And we provide the config.in. There we go. Alright, so let's see here. We want to compile everything statically. So it's probably inside of settings. Shout if you see static somewhere. Let's see, use static libgcc. Can we search for static? Build static binary. Location settings. Okay, so it should be here. B. Here, build static binary. So say yes to this one. We exit and save. All right. And before we start doing any of that, let's move Linux to phase 1. And let's also go into phase 1 and create a directory called root. So this root directory is going to be the installation prefix. It's going to be this directory where we install everything into. So if we do pwd and we check our path, so this is our path, and let's define a variable. So let's say root is equal to this and the root directory, and we export root. So now I have this root that we can use everywhere. And let's do the same in every window. And here as well. Well, let's set our home directory. Let's set our root. Let's export our root. Alright, so now we'll just run make. And by the way, if you have multiple processors or cores on your system, you can check that by running nproc. I have 8, as you can see. So in order to make the compiling go faster, you can run make-j and 8 in case of 8 processors. So let's do that. By the way, we want to set the destination prefix as well. Maybe we do that in the config somewhere. Let's search for prefix, capital letters, config cross compiler, that's not it, config prefix. Let's search for prefix. Destination path for make install. Okay, that's the thing. So let's go to settings and let's see where we have it. Installation prefix. Here. So let's grab this whole thing and put it right here and save. And now we can run make-j8 and boom, we start compiling stuff. Alright, so that's one. The next thing is the Linux kernel. So let's go into that one. And we start by running make Mr. proper. And many YouTubers don't do this step if they have just unzipped the thing, because they think that this is unnecessary if everything is already clean. But you can't, in the Linux kernel documentation, it says explicitly that you cannot trust that everything is clean only because it's delivered as a tar GC. So always start with make Mr. proper. And now you have two choices depending on the architecture. So if we run make help, you can see that we can run i386 defconfig if we want a 32-bit system, or x86-64 def config if we want the 64-bit version. So I'm gonna run this like so. And let's unpack glibc. We are working on multiple fronts at the same time. And it seems Busybox is done. So let's run make install. And we don't need to sudo since we use a prefix in our own directory structure. Okay, so let's go into our root and see what we got. So if we go to bin, we have a lot of stuff here. Everything linked to Busybox. And does it work? Let's run ls. Seems like. And we also have some system binaries in here, quite many. So when we install something, some other package like bash, we first go in here and we delete the link, and then we install bash, so we don't overwrite this Busybox binary. And it created this annoying user directory which I loathe. That's a little bit annoying. I guess we can't just move these links either, because then this path will no longer be correct. Maybe we can do some ninja stuff. If we iterate over everything inside of here, and then we create a new link where we link our $root bin Busybox, and we link it to $root bin name of the file. Done. Oh, it should be for I in this. Okay, no error. So let's see, if we take who am I, for instance, and we check okay. I was in this directory. So what does that mean? Does it mean I created a bin? Yes. Okay, so let's remove those and do this again. Probably created a Linux RC and a sbin and a user. And now we go into the user directory. We go into the bin directory. So these are the ones. So let's run our command again, like this. And let's check in our bin directory for one of these. Let's say make password. Alright. But this is no good either. We should actually point it. Let's rerun this. And let's remove $root bin $I, and we relink it against Busybox in the same directory. Can we do that? Need to move this do. And let's check this make password. Okay, so now it points correctly. And we can do the same with sbin, because here we have a lot of stuff as well. And we don't need this rm thing. So for everything, we create a link for Busybox. Sbin. Actually, in this case, it becomes this, because we are in the sbin directory, and we go one step up and then into bin. And this is sbin and done. So let's check in our sbin. Do we have a kill all file? Yes. Alright, nice. So now we can remove that whole user directory, which I loathe. Really do not like that. And we don't need a Linux RC either. Okay, now it's clean and nice. And we have a def config, so now we can run menu config, because we do need to change just a couple of things. I'm not going to be too picky with that, since we're going to have a very optimized kernel for the real Linux distribution, but for phase 1, I'm basically going to have all defaults except a few things. So let's see, let's configure glibc, and we set the prefix to our $root. Okay, you need to do it in a separate build directory. So we create a build directory and we run configure like this instead. Dot, like so. And here is the menu config for the Linux kernel. So we don't want virtualization. We don't want loadable module support. If you are creating a 64-bit kernel, you need to have this one checked, but I don't. And we don't need to have these either. We do want this for the real thing later, but now it's only unnecessary. Otherwise, I think I want to keep most of these. Yeah. So let's exit and save. And now we run make-j8. And this is going to take quite a while. But we have some stuff to do while we wait. So let's start by compiling glibc. So make -j 8. And what else? We can't do sysv init because we need glibc. Busybox is done, Linux kernel and glibc is currently building. Bash. So let's go to gnu.org. And why do we need bash? Why can't we use the shell which comes with the Busybox? That's because our installation program is going to be coded in bash. So we need all the scripting abilities. That's why. So let's search for bash and go to its directory or page. We go to the download and select a good enough version. So let's see, bash 5.3 sounds good. That's the newest one. And we copy this link to the tar gz. And we download it into our phase 1 directory. And it's compiling. That's not good. Maybe I took too early release. Annoying. They changed so many things in every version that it's not possible to compile any longer if we want the older version. Well, that breaks my plans for that part. But not much to do. We have to install the latest version then. So let's go to libc. And download. And let's grab the latest thing. So 242 then. So let's delete the old. And download this instead. Alright, so now we're compiling the kernel. We are downloading the new glibc. And we are downloading the bash. And since I've already showed you how to do the glibc, when this is done, I'm gonna start the compilation step. So let's take a break until those are complete. See you just in a bit. Alright, so welcome back you guys. Now the glibc has completed. So let's run make install. And this should be fairly quick, I think. And hopefully everything will be installed into the right location. Meanwhile, we can take a look at the kernel, which is also done. Which means now we have this BZ image, which is the entire kernel. And yours might be in another directory. So you see it's architecture x86 for me. Perhaps it's x86 64 or something for you. But it might also be the same. So look what it says on this line right here. Um, all right. So this is not enough though. We won't just create the kernel image. We will also need to create an ISO so we can boot our entire file system. And for that we are going to use a make option, which is make ISO image. So you need to install some packages. You need ISO, let's see, what's it called? ISO Linux, I think the package name is. When you try to run make ISO image and it fails because you don't have the right package, it's going to tell you what package to install. But we need to use these arguments as well. We need to tell it what image that we're going to use for our file system. And we can't do this as of yet because we have not created everything else for our file system. But we're getting there. So glibc is done. So if we go into our root now, we have a couple of directories. We have a lib directory, and this is where everything important lives. Here is the interpreter, the loader of executables, and this is the libc library. So these are the two most important. I see that it created a user directory again, or didn't it? No, I saw wrong. It put everything inside of lib directly, which is exactly what I wanted. Perfect. Okay, so now glibc is done and we can start doing the other ones. And we can, let's see here, we can start with bash. And we want to link this to our specific glibc version, which means we need to add that to the make file. But let's start with doing a regular configure. Let's just set the prefix to our root. And meanwhile, we can download another package, which we're also going to need, which is sfdisk. Let me just double check that this is the right name. Let's do echo sbin fdisk. Right, so sfdisk. There are a couple of different. My favorite is cfdisk. It's very easy to navigate using an ncurses console-based interface. The regular fdisk uses commands and prompts. But for our intents and purposes, which is scripting, since we're gonna create partitions based off of a script, this is perfect because we can read from a configuration file basically, which will create all the partitions for us. So sfdisk we need, and I'm not sure if that is a GNU package. Let's see if it's here. So let's search for fdisk. No, only the regular one is GNU as it seems. So let's Google, let's see that we find the right one. So let's run sfdisk-version from util Linux. Okay, maybe it is actually part of GNU. So util a lot of different utils. But I don't find util Linux. Let's Google for that. Util Linux. It's a random collection of Linux utilities. It has a Wikipedia page distributed by the Linux kernel organization. So it looks pretty. And we can find it on the kernel.org page. So I think we can be pretty sure this is okay. So let's see, I have 238.1. 238. Well, let's take the newest one. So util Linux. This one right here. Copy link. And we can wget this thing. So let's see. Okay, so bash configuration is done. Let's check the make file and see if we can edit some stuff. So we have the prefix here. It referenced data root here. Prefix share. So that will be /share. I actually want to use var share. I want to see if we can add some additional flags to the C compiler. C tags flags. I'm not sure what they mean by C tag. Is this run for every one? let's see, if we run configure and help, and we grep for libc, link, we can link it statically. LD flags. Libraries to pass to the linker. Let's try that. So I have saved how we do that, how we link to another glibc. I call it rpath. So this is what we want to pass. But it's not libraries, but maybe it still works. So configure, and we set the prefix to root. Let's check again how we did this. Libs. Let's check the whole thing. Some influential environment variables. Okay. Do we have something in libs already? Nope. So let's say we set libs to this. We export libs, and then we run configure again. Like so. Meanwhile, we can unzip utils Linux. And we also need to have a bootloader. And I don't really want to use grub if I don't have to. It's too much bloat. Okay, so let's check the makefile again. Did they change our changes? Data root dir. This we want to be varchar. Support an alternate destination root directory. Okay, so libs actually took our flags. Maybe this will work. Let's see what happens. If it doesn't work, linking against it, we can do it manually afterwards as well. Since bash is just one binary file, it's quite possible. Quite manageable, actually. So what bootloader do we want to use? I would want to use Lilo. That is the most clean loader, Lilo. I think it's GNU. User manual Lilo. So where can we find Lilo? Here. Wonder if it still compiles. $2026. Well, let's copy this link and see what happens. I would be very happy if I could use Lilo for this project. Okay, we have a bash. So let's do an LDD on this bash and see what it says. /lib ld Linux. Okay, so the interpreter is pointing to the correct stuff. And libc is not though, but sometimes when we don't have that, because we don't have lib and this file on our current system because it's in this root directory, right? So first when we actually use this image and reboot into Linux, it's going to be stored in /lib. So I think this is showing wrong actually. What we can do is running patch elf. And we check the R path. So the R path is the path to the lib directory where libc is found. So can we show R path? Add R path, remove, set R path, print R path. There we go. /lib. Okay, I think this is right. So let's make install. By the way, before we do that, let's remove the symlinks. So let's see. We have, okay, we don't have a bash here. Do we have an sh? That we do. So let's remove sh. Let's go back into bash. Make install. A lot of stuff. Then we go into the root. And bin. And there we have it, bash. Maybe we can strip it. It seems a little bit big. Okay, that's better. And we still will not see the right thing here. But I want to link this to sh. So bash becomes our standard shell. Okay, so bash is done. And libc is done, Linux kernel is pretty much done. Sysvinit is next. And Busybox is done. Maybe we can change mode 0 the stuff that we are done with, just to make it visible that we are done with it. Not Linux though, because we need to do some more stuff there. So now we quite nicely see which are done and which are not. Okie dokes. And now we have Lilo, we can unpack. And let's take before we continue, I think it's time to test out if our image works this far. So what we need to do is create the image. And how we do that is we need to take an image of all of this stuff here. And by the way, we need to have something which is run when we start the operating system, since we don't have sysvinit in it yet. So I'm going to symlink bin bash into init in the root directory, because that's what's going to be run on boot, so to speak. Alright, so how do we create one of these images? What we do is we select what files and directories to use by just doing a find, which will list all directories and files and subdirectories. And then we pipe this to CPIO, which is the packager. It's like WinZip or tar. And we need to provide what format. It's called new C, the one which is used for the kernel stuff. Let's see here. And then we do -O for creating a new archive, I think. And then we want to gzip it. And then we pipe all of this into, let's call it init RAM disk, because this is going to be a RAM disk. CPIO GZ. Something like this. So now it basically zips together all of these files in our root. And now we have it here. So let's take the current directory and our file and put it into some kind of variable. So let's call this init rd path. And let's export init rd path. Now we go into the Linux, make help. So what we want to run now is make ISO image. But we also need to specify these things. So this is going to be the thing we prepared. So init rd path. And then we need some fdargs, and this is just what we are going to send to the kernel. So let's see here, we need a couple of things. We need to set our init RAM disk to our init rd CPIO GZ, and here is it's going to be in the root directory of the disk image. So that's what we're referencing here. And we also, since we are using, since we haven't mounted all of the stuff like the devices and so on, we will not be able to use the console with current settings. So temporarily, we need to set the console to TTYS0. So this parameter will create a file inside of dev console, a symlink, pointing toward the device driver for the terminal. And this we only need temporarily, until we have fixed everything with the init script and so on. Alright, so I guess this is it. And then we say ISO image and see what happens. And it has already compiled the kernel, so all it does now is creating the ISO and adding some simple bootloader to it, so we can just launch that ISO image in a virtual machine, for instance. And while it is doing its thing, I'm going to show you one of my aliases which I have created, because I'm going to use the QEMU virtual machine, and I'm using the i386 version, but yours might be x86 64 or something. And I have the no graphic, so we don't need to create any windows, but be using the console as the virtual machine. I set the memory to 512. We also need to set VGA to the standard and display to curses for everything to work with our current setup. And I'm just creating an alias called VM, which does all of this, so I don't have to type it all the time. So you can just paste this into the terminal and press enter. All right. So now we should have this thing right here. Cool. Let's go into the phase 1 directory here. And symlink Linux. Let's first symlink the Linux directory into a directory called Linux. And then we symlink Linux/this into image.iso. So we have it available here in an easy enough kind of way. So now we should just be able to run VM, our alias, and say that our CD-ROM is this image. Let's see what happens. So it's loading. And something is happening. Kernel panic. That's pretty interesting. Error while loading shared libraries. libtinfo. Cannot open shared object file. libtinfo. Because it's okay, it's bash. Let's double check our bash. That's right, libtinfo. Do we have something like that inside of our lib? tinfo. I'm not even sure what libtinfo is. Oh. Maybe we can cheat a little bit with that one. If I check my user lib directory for tinfo, it's in lib i386. Okay, so here it is. libtinfo so6, libtinfo so64. So it's this one right here. If we do strings on that thing and we grep for /lib, It's referencing a couple of other things, but I'm not sure if that is a problem. I guess we can't run LDD on the thing. Oh, we can actually. /lib ld linux. And if we do patch elf and we print the R path of that library. No, not that one. This one. Okay. So, let's try copying this thing to this lib directory. And let's link it. Let's see, what did bash look for? LDD bin bash. So libtinfo SO6. So let's link this against this name right here. And then we patch elf. Set the R path to dev for bin bash. Oh, we should have space here. Okay. Let's see if it took. Oh, it shouldn't be dev. It should be lib. Glad I checked. All right. So now we are probably okay. Think we should be at least. Let's double check so we don't recreate the ISO and it fails again. If we do strings on our bash, we grep for libtinfo. Okay, so it just specifies the file name and the rest it takes from the R path. Great. Okay, I think we're okay. So let's rerun the cpio command. No, not that one. cpio space. Here it is. So we recreate this image file. And we go back into the kernel. We run the other CPIO command. And make, right, this one. So we don't need to recompile anything in the kernel or so. All we need to do every time we make a change is recreate the CPIO and run make ISO image. So maybe we should put that inside of a script or something, because I figure we're gonna do it quite often. Alright, so hopefully everything will work this time. Let's rerun our VM command and see what happens. And we did cheat a little bit with this library. We did not compile it ourselves, but this is only for phase 1. So this is not going into our destination system. Ah, look at this. We have a shell. Great. And everything seems to be working fine. Well, we don't have any file systems mounted, but we do have access to all of this stuff. So, great. Now we know that everything works this far, and I think this would be all for today. In the next episode, we are going to continue creating this thing and also code the entire phase 1 installation system with partitioning and everything. And I really hope you liked this episode. Please like and subscribe. And thanks for watching. Thanks for today.